Today we're going to be teaching you about numerical integration, which deals with area of a function, and you'll most likely see this concept on your exam, so it's very important. We're going to teach you about a right Riemann sum, a left Riemann sum, and a midpoint Riemann sum, and all of these just deal with rectangles. And we're also going to teach you about a trapezoidal sum, and it's important to know that the area of a trapezoid is 1/2 base 1 plus base 2 times height. So first, we'll start with a right and left Riemann sum of this function.
This time we're going to start with the left Riemann sum. The figure above shows the rate at which the files are processed at an office during the time interval 0 to 18 hours. In order to do the left Riemann sum, you start with the 0. So you go 0
Integral.
times, well, you're going to do the integral of it, or of t. So we're going to take the integral of that, which is 0 to 18. And then it's dt because you're taking the antiderivative. Okay, so first you're going to do 0 times the change of 0 to 3. So that's just 3. Plus, then you go to 30, and the change is still 3, plus 33, and the change is still 3, plus 31 times 3, plus 39 times 3, plus 42 times 3, and then you don't do the 45 because this is the left one. For the right one, you're going to start with the 30 because it's the right one, and you're going to so all the left ones, and you don't count the last one for the left one. So the answer for this, when you add all these up, you get 525 as your answer. For the right Riemann sum, you do the same thing, but this time you're going to start with the 30. So you're going to take the antiderivative from 0 to 18 of r of t dt, but this time start with 30. So 30 times 3 again, because it's still the change in time, plus 33 times 3, plus 31 times 3, plus 39 times 3, plus 42 times 3, and this time you are going to include the 45 because it's a right Riemann sum. So plus 45 times 3. And the answer when you add all this up is 618. So this is how you do the left and right Riemann sum. Taylor's going to...
Okay, so now that we have done a right and left Riemann sum to find the total number of files processed, we can work on a midpoint and a trapezoidal sum. The midpoint, you would be asked to use 3 different subintervals to find the total number of files processed. So for this, we're going to look at 30, 31, and 42 because each one has a number on each side of it. So for the midpoint, we're going to use the interval from 0 to 18 hours, r of t dt, and we're going to multiply the 30 times 6 because that is the change in time, and then we're going to add to that the 31 that we underlined times 6, and then the 42 times the 6 because each one has a change in 6 hours. And when we add those up, we get 618. And then the trapezoidal sum, we need to use the area formula, so we're going to use the integral from 0 to 18 r of t dt, and this one requires a lot of writing. It's going to equal 1/2 base 1 plus base 2, so 0 plus 30 times the change in t, which is 3, plus 1/2. 30 plus 33 times 3 again, plus 1/2. 33 plus 31 times 3 plus 1/2. 31 plus 39 times 3 plus 1/2. 39 plus 42 times 3 plus 1/2. 42 plus 45 times 3. And that is going to equal 592.5. And I actually think we might have made a mistake for the right sum back here. For the right sum, we had told you that it was 618, but it is actually 660 when you add that up. And this right here is how you do a numerical integration problem. Thank you.